In this video, I will discuss about the basics of electromagnetic flow meter, which is also known as mag flow meter. The mag flow meter is widely used in process industries because of its various advantages. This mag flow meter works on Faraday's law of electromagnetic induction, and this is the basic law of electromagnetism that predicts how a magnetic field will interact with an electric circuit to produce an EMF. Not only electromagnetic flow meter, a device like transformers, inductors, electric motors, generators, solenoids, etc. will work on this Faraday's law. If a magnetic flux through a circuit changes, an EMF and current are induced in that circuit, and this is known as Faraday's electromagnetic induction. And the equation is given by EMF equal to N into d phi by dt, where N is the number of turns of the circuit and d phi by dt is the rate of flux change. Motional EMF. Faraday's law of induction can be used to calculate the motional EMF, and this is the basis for the operation of the electromagnetic flow meter. And as per the equation, an EMF is induced whenever there is a change in magnetic flux. And in electromagnetic flow meter, this change in magnetic flux is caused by a moving element in a system, that is conductive fluid. Consider the area that is enclosed by the moving rod, that is conductive liquid, electrodes and measuring device, that is represented by the resistor or as shown in this figure. B is perpendicular to the area, and the area is increasing as the rod moves. Here we can see the initial position of the rod is shown as in the dotted line, and whenever the rod moves, the area increases, and whenever area increases, the flux increases, because the flux is equal to the product of the magnetic flux density B and the area. When flux changes, an EMF is induced according to the Faraday law of electromagnetic induction. The equation can be derived: EMF equal to minus N into d phi by dt. So where phi is given by magnetic flux density into area, so in our case N equal to 1. So if you submit here, so EMF equal to B into L, where L is the distance between the electrodes, which equal into dx by dt. Dx by dt is the velocity. If you submit all in this equation, finally you will get EMF equal to BLV, where B is the magnetic flux density, L is the distance between the electrodes. It is also can be taken as D, that is diameter of the pipe, and V, where V is the velocity of the moving fluid. This is a typical diagram of the electromagnetic flow meter. Here we can see the velocity of the moving fluid, magnetic flux density B, EMF that is induced are perpendicular to each other. So once the magnetic field is fixed, that is constant, and diameter of the pipe is fixed, the magnitude of the EMF that is induced is proportional to the velocity of the moving fluid. The liquid can be considered as infinite number of conductors that are moving through a magnetic field, with each element contributing to the EMF that is generated. An increase in flow rate of the liquid conductors moving through the field will result in an increase in the instantaneous value of the voltage generated. That is, higher the velocity of the fluid, higher will be the EMF that is induced. So the EMF which we have derived, V equal to BLV or BdV. So how to calculate volumetric flow rate from this EMF? So in order volumetric flow rate, Q equal to A into V, where A is the area. So area is known because the diameter of the pipe is known, and V is the velocity which can be calculated from the EMF. If you submit in this equation, we will get Q equal to pi D, where D is the diameter of the pipe, or distance between, or it is also known as distance between the electrodes. Where V is the EMF that is measured, by 4 into B, where B is the magnetic flux density. So the main advantages of the electromagnetic flow meter is obstructionless, and it is having no moving parts. So because of this, there is no pressure drop, and pumping cost are thereby minimized. This is the main reason magnetic flow meters are so famous. So the meters are widely used for slurry services because it is not having any obstruction. And not only this reason, so it is using liners such as polyurethane, neoprene, rubber, etc., that are having good abrasion or erosion resistance, so which will improve the life of the electromagnetic flow meter. And these electromagnetic flow meters are bidirectional, which can measure the flow in both the directions, and it is having high dynamic range, so it can having dynamic range of 1:20. So it is can measure the very low to high flow rates by using the same flow meter. In addition to these advantages, there are some of the disadvantages, like the measuring fluid should be conductive, and the minimum conductivity is specified by the manufacturer. So thank you for watching my video.